Hello again. This will be the second video. It's going to be very short, and we will be talking about partial derivative. So by now we know how to differentiate a function involving a single variable in the first video. And then now we shall consider cases where there are two or more differentiable functions, each of which has a distinct independent variable. For example, if we have a function of let me write it here, where f of x and y is equal to x squared minus x of y plus y squared. So we have two differentiable functions, each of which has a distinct independent variable. So we have x and y, which both of them are independent. Now, when we see a function like this, then the situation becomes more complicated. However, when we study the rate of change of the function of two or more variables, the obvious analog for a function of two variables, which is g of x and y, would be something that tells us how quickly g of x and y increases as x and y, which is our two argument, would be something the x and y as x and y increases. Now, in most cases, this will depend on how quickly x and y are changing relative to each other. So how do we take derivative of function of involving a multiple variable, like in this example? To solve this kind of problem, we need to use a special method, and that method, what a process is called partial derivative. And then I'm going to have an example for you, and we're going to work this example together. Now, the example we have is the following. So this is an example. We have f of x and y, and that is equal to x squared plus x and y plus y squared. So now we can see that we cannot take the derivative using a simple derivative with respect to x and y. So now what we do is that when we take the derivative of the function with respect to x, we treat y as a constant. And then when we, for the second time, we take the derivative of this function with respect to y, then we treat x as a constant. Let us take the derivative of this function, a partial derivative of this function, with respect to x. How do we do that? You can either use this symbol. This is a partial of f of x and y. Usually you put x here, or you put with respect to x like this, or you can write it f of x and y, and then you take the derivative. It means that you're taking the derivative of this function with respect to x holding y constant. So that's what we take. So let us take this example. So that's the functions that we have, and let's take the example. Now this is equal to, we take the partial derivative of this function with respect to x of x squared plus x and y plus y squared. Now separate these terms, makes it easy for you, and you won't make any mistake, or you probably make less mistake, I should say. So if we do that, then you separate. So we take the partial derivative with respect to x of x squared, the first term. And then we have plus, because we're taking the derivative with respect to x. It's better to write y and then write the derivative, partial derivative of this function with respect to x of x. So put a bracket, it makes it much easier. And also you follow the sign, and then you take partial derivative of this function with respect to x of the third term, which is y to the power, sorry, this should be power of 5. It doesn't matter, but I just put in 5. So to the power of 5. Now, you apply the rules of derivative, how you take your derivative. So the partial derivative of x squared is 2x you write plus y, and the partial derivative of x with respect to x is 1, and then plus the partial derivative of this third term of y to the power of 5 with respect to x is 0 because we don't have any x here. So when we don't have an x, then since we're holding y constant, therefore the derivative of constant is 0. Therefore, the derivative, the answer will be 2x plus y when we take the derivative of this function if of x, x, and y is equal to this. Now we are holding x constant, and we take the derivative of this function with respect to y. So same thing, f of y of x and y is equal to a partial derivative with respect to y of x squared plus y, xy, so suppose x and y, and plus y to the power of 5. Again, you separate these terms. You can do partial derivative with respect to y of x squared, and plus, because you have x and y, since you write taking the derivative with respect to y, then it's always best like we did here, we put y here, so we put x and times the partial derivative with respect to y of y, and then plus partial derivative with respect to y of y to the power of 5. Again, here, this is 0 because the partial derivative of x squared with respect to y, there is no y, therefore x is constant, it is 0. Then we have plus x, so we have plus x, and then we have times the derivative y is 1, and also plus the derivative of y to the power of 5 with respect to y is 5, y to the power of 4. Now I'm going to go to the next page. Then we have, okay, let me go to the next page. So we have f of y and x and y is equal to x plus 5y to the power of 4. Now, so this is how you take the derivative of a function when you have a multi-variable. In the next video, I'm going to have another example, and stay tuned.